This is the trickiest of them all. This involves a scolem function. So pay attention. Very simple looking sentence. Every student reads some book. Very misleadingly simple looking statement. Okay. Of course, you have the clause student X, and you can say book. Now I'll use a different variable name over here. I can also use book X, but simply because in the next predicate I want to say reads X comma Y, so already I used Y for the book. So this is basically X reads Y. Okay, X reads Y. So now what the actual statement is saying is that for all X, every student, so student is student has the quantifier for all X, but they don't read all the books that exist on this earth. They read some books. So student X implies there exists a book Y. Okay, there exists a Y such that Y is a book, okay, and reads X comma Y. Now what is happening over here? Okay, now this for all applies to the entire thing. So what is happening over here? For each student, there exists some book that the student reads. Different students may read different books. That's why this will not work with only a single scolem constant. We cannot use a scolem constant over here. Scolem constant. Okay, it's not like there is some book that every student has read. So in that case we could have said that let Y be equal to B1. Let Y be that B1, that particular book that everyone has read. Maybe the alphabets in the childhood or whatever. But it is not what this statement is saying. This is not what the statement is saying. This statement is saying that the book is a function of student. That means book depends on student. Okay, student X. So book Y depends on student X. Okay, every student may have read some different book, but they have read some book. Okay, so now we have to replace Y with fx. Y is a function of X, right? So now what our rule will become is, along with implication, so this will be okay. So this was our initial rule. When we drop the implication, this becomes for all X, not student X. I'm not removing the universal quantifier on purpose. Okay, there exists Y, just to drive home the point that there is an existential nested quantifier inside and a universal quantifier outside. Okay, it is X comma Y. Okay, so now we can take there exists Y outside. Okay, because there exists Y does not affect this. We can take there exists Y outside. It will not change the meaning of this sentence. Okay, because it's not affecting this particular, this does not have any Y. So we can very well remove there exists Y outwards, or book Y and reads X comma Y. Okay. Now we can okay, so this is basically in its own bracket, right? This is in its own bracket, right? So what we can do is we can distribute or over and. So what we can say is for all x there exists y. Okay. Not student x or book y and not student x or reads x comma y. Okay, and now in order to eliminate, now we'll perform scholemization. Now when we perform scholemization, this scholemization will use the scholem function that we discussed over here. Okay, so now we'll replace y with f of x. So for all x there exists y is gone. So for all x not student x or book, which is a preference, like which depends on the student which book they are reading. Okay, and not student x or reads x comma fx. Okay, it depends on the student which book they are reading. And of course we can drop the universal quantifier. Okay, this can be dropped, universal quantifier can be dropped. Okay, so this will be our answer. This is conjunctive normal form. Each atom inside may have or a single atom, and then they are connected with and. So this is our answer.